Hello everyone, welcome to our daily physics problem, day number 44. Today we are going to initialize this double pulley system with three masses configured below and being released from rest. Find the accelerations of m1, m2, and m3 respectively. So I want you to pause the video, try your own. After you try it, come back to the video and we will solve it together. So welcome back guys. So first we are going to draw a free body diagram that label all the forces. We have the gravitational force m1g, m2g, m3g directly pulling on three masses downwards, and then the tensions. Let's define the tension on the right pulley as T1 and the tension on the top left pulley T2. Then we can use some Newton's law to find out some system equation and to try to solve it. First, let's consider the right pulley as a whole black box. We consider a blind mass in order to calculate the acceleration of the m1 mass. So how do we do that? Well, we know that the acceleration of m1 is equal to t2 minus m1g divided by m1, right? And then the right pulley, right system, we have t2. We have because right pulley we consider a mass. The force pulling down is equal to 2t1 because 2t1 are pulling downwards on the right, and then minus the t2, which is the force tension pulling upward, divided by 2t over g. 2t over g is the equivalent mass of the right pulley system. So we put g upward because it's reciprocal, divided by reciprocal is multiplied by g. Then we have this first equation. And then we have 2t times t2 minus m1g. T equal to m1 times 2t1 g minus m1 t2 g. Oh, we've got this g here. Then we move the m1 t2 g to the left, minus 2m1 gt to the right. We combine with this equation, and then we try to solve for t2. That will be t2 equal to 4m1 gt1 over 2t1 plus m1g. Then you probably want to ask, what is T1 then? Well, in order to find T1, we have to look at the bottom pulley. In the bottom pulley, we know the acceleration of M2 and M3 have to be equal magnitude, opposite in direction. So the magnitude of them have to equal, so T1 minus M2G divided by M2 have to equal to M3G minus T1 over M3. Then we solve this to get this equation, and then we try to plug in, and we try to combine the terms. Then we find T1 is equal to 2 times M3 M2G divided by M3 plus M2. We forgot these are all ones. Yes, it's all one. Then we plug into this equation to find T2. So T2 equal to 4 M1G times 2 M3 M2G divided by M3 plus M2 divided by 2 times 2 M3 M2G divided by 3 M3 plus M2 plus M1G. Then we cancel out one of the g's, and m1s, oh actually no m1s, there's another term that we cannot cancel, so we simplify it. We get is t2 is equal to 8 times m1 times m2 m3 g divided by m3 plus m2 times 4 times m3 m2 divided by m3 plus m2 plus m1. We forgot the g there, we need to add it on later. T2 is equal to 8 times m1 m2 mg divided by 4 times m3 m2 plus m1 times m3 plus m2. So now we know the tension T2. Plug into the original equation, we can find out the acceleration, which is T2 minus m1g divided by m1, which is a1, this acceleration of mass 1. Then we plug in, we get this T2 plug in minus m1g, or divide by m1, so we can divide by m1 is equal to a1. Then we have 8 times m2 m3 minus 4 times m3 m2 minus m1 times m3 plus m2 over 4 times m3 m2 plus m1 times m3 plus m2. G is equal to a1. Now simplify, we get a1 is equal to 4 times m3 m2 by minus m1 m3 plus m2 divided by 4 times m3 m2 plus m1 plus m3 plus m2. That's our solution for A1. Very, very beautiful. Now let's find out A2 and A3. So what is A2 equal to? Let's first consider a scenario where the right bottom pulley is not accelerating downward. Because now here is accelerating downward, which means we probably need an inertial force there. So we first assume that the right pulley is not falling. Okay, so it's stationary. Then we see how the A2 and A3 will behave. So since we know they are on the same string, so we're going to cover some conservation of string, then we know they have equal magnitude of acceleration, which is here we already calculated. We know T1 minus M2G divided by M2 is equal to A2, and T1 we already know, plug it in. We find out that A2 is equal to this expression. We cancel out the A2s. We have 2 times M3G minus 2 times M3 minus M3 minus M2 divided by M3 plus M2 times G go to A2. So A2 is equal to M3 minus M2 divided by M3 plus M2 G. That's the magnitude of A2 acceleration when the pulley is not accelerating. Now, since we know that the block, or actually the right pulley is falling, so we need to consider the inertial force to remodify the gravitational acceleration, G. The equivalent gravitational acceleration is not G anymore. Since the block is falling, G should be smaller than expected. And we need to add back the acceleration of the caused by the block 1. So we have using the principle of superposition. So after we know re-ratify the gravitational acceleration, we add back the falling acceleration. Understand? So first assume that A2 is falling, or they are both falling downwards, but A2 is falling downwards respected to A3, like for example. So let's copy this term down. Oh, actually, we forgot this G here. Let's put a G here. That's important. So A2 will be equal to M3 minus M2 plus divided by M3 plus M2 times the remodified gravitational acceleration. Then minus the A1, which is according to the superposition principle. Then we just solve this freaking equation. It's freaking long. I know it's really long. So let's bear with me and solve this together. First, let's move the term combinating the denominator and a denominator. Move out the G, and then we put another G here. It's pretty long. And then we try to do another. First, we just multiply in the M3 minus M2 divided by M3 plus M2, and then we renormalize the finding out the common denominator, right? So now we find out this expression, and then we divide by M3 plus M2 times 4M3 M2 plus M1 times M3 plus M2 times G entirely. There's a G here, and then we just multiply this again. Let's move this to the right. Oops. Move this to the right and put a G here. Okay. And then A2 is equal to M3 minus M2. We found out that these two terms cancel out. So what we have left is 2 times M1 plus times M3 plus M2 times G over M3 plus M2 times 4M3 M2 plus M1 times M3 plus M2. And then minus 4 times and minus this whole expression again times G. So now we just combine these two expressions. Common because we all have G. Let's factor out the G. So we have 2 times M3 minus M2 times M1 minus 4M3 M2 plus M1 times M3 plus M2 divided by 4M3 M2 plus M1 times M3 plus M2 times G, the entire thing. Then A2 is equal to M1, factor out M1 times 2M3 minus 2m2 plus m3 plus m2 minus 4m3 m2 divided by 4m3 m2 plus m1 times m3 plus m2, entire thing multiplied by g. Then we simplify this a little bit more. We find out that a2 is equal to m1 times 3m3 minus m2 minus 4m3 m2 divided by 4m3 m2 plus m1 times m3 plus m2 times g. And that is our a2 expression. And a3 is very similar to a2. I just copied it down because we know a3 is moving opposite direction to a2, assuming that the pulley is not falling. So we just put a negative there. Remember, we do. So the algebra is pretty similar. We just not gonna, for the sake of time, we're not gonna repeat them. So let's just tell you the result. A3 will be equal to m1 times 3m2 minus m3 minus 4m3 m2 divided by 4m3 m2 plus m1 times m3 plus m2g. And there's a symmetry there. So here is our answer. Thank you for watching.